All right, so we're in section 13.3 where we get to evaluate trig functions of any angle. First thing we have here in the green box is what is called the unit circle. You should have a handout of the unit circle at the start of chapter 13, which helps you identify different values of theta through different trig functions. What we know about the unit circle is that the radius of that circle is always going to be 1. And the center of our circle is always going to be at the origin 0, 0. So using this box here, it's gonna help you identify what angle is for theta by determining what our x value is and what our y value will be. So, but in this particular instance, sometimes our coordinates won't always dictate through the unit circle with the radius being 1. Kind of like what we have here in our examples A and also example B, which is on the bottom. First thing they want you to do is they want you to evaluate the 6 trig functions for a terminal side of an angle theta and then put it in standard position. So if you were to look at this graphically, we would have a graph here, and I know that I would have the coordinate of 6, 8, which would be located somewhere right around here. And which means that I have some radius r, where this is located at 6 units, and this is located at 8 units. So this is going to give us a right triangle. So, which means if this is a right triangle, I can use the Pythagorean Theorem, which is a squared, which will say that's 6. So 6 squared, which is 36, plus 8 squared, which is 64, will give me r squared. So 36 plus 64 will give me 100 equals r squared, and r is going to equal 10. So by knowing all of these values, I can then find what sine of theta, cosine of theta, tangent, cosecant, secant, and cotangent of theta are located. So again, sine is opposite over hypotenuse, so in lowest terms is going to be 4 over 5. Cosine, it's going to be adjacent over hypotenuse, and in lowest terms it's going to be 3 over 5. Tangent is going to be dictated by y divided by x, and in lowest terms that's going to be 4 over 3. And then cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent respectively. And I have, it's going to be 5 over 4, 5 over 3, and 3 over 4. Same thing goes for -9, -40. So if I were to make, an XY chart here, I would have it at -9, it's going to the left, then 40. So it looks something kind of like this. Even though it's not the scale, this distance here would be the -9, and here would be the -40. So if I wanted to find what r was going to be in this particular case, I would say whatever 40 squared, which is 1600, plus -9 squared, which is 81. Take the square root of this. My r, in this case, is going to give me a 41. So we have to keep in mind our not only what our trig values are going to be, but we also have to keep in mind that we have some negative values. So I got sine, cosine, tangent, cosecant, secant, and cotangent. So theta is coming off of here, off of our reference angle, and it's going to be opposite over hypotenuse. So opposite's going to be what? Negative 40 over 41. Cosine theta is going to be negative 9 over 41. Tangent is going to be negative 40 over negative 9, which equals positive 40 over 9. And now these are just the reciprocals. So this is going to be a negative 41 over 40, negative 41 over 9, and 9 over 40. Okay? And this is kind of what I was talking about earlier about the unit circle. You know, the unit circle is a circle with the radius of 1, and it allows us to find what x and y will be located respectively with through that unit circle. So if I had, kind of using the same concept as I used in the first steps, they want us to find and evaluate the 6 trig functions for 2 pi. And if we tried to take 2 pi and convert it to degrees, because that's in radians, I'd multiply this by 180 over pi. Pi's cancel. This gives me 360 degrees. So in essence, 2 pi equals 360 degrees. So if I were to make this on a graph, you know, with the unit circle in mind, it's going to be located right about here. The coordinate for this particular spot is at 1, 0. And we're going to use the same steps as we use for A and B to help us find the 6 trig functions. So I'm going to find sine of 2 pi, cosine of 2 pi, tangent of 2 pi, cosecant of 2 pi, secant of 2 pi, and lastly cotangent of 2 pi. So like above, we're going to use y divided by r. Well, r here is always going to equal a positive 1. And y in this case was 0, so it's going to be 0 divided by 1, so the sine of 2 pi is going to give me 0. Cosine of 2 pi can be 1 divided by 1, which gives me 1. Tangent of 2 pi is y divided by x, so 0 divided by 1, which gives me 0. Cosecant of 2 pi gives me 1 divided by 0. Since I can't divide by 0, this is going to be undefined. For secant, it's going to be 1 divided by 1, so I still 1 again. And then cotangent is going to be 1 divided by 0, so that's also undefined. Next thing we're going to do is we're going to try to find the reference angles of our various equations, keeping the unit circle in mind. Reference angle is a acute angle formed by either the terminal side, which is the right-hand side of my x-axis, or the other side, which is the negative portion of our x-axis. If you look at our chart here, we have different ways of writing a reference angle, whether it's in your original angle is in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. So when you're looking at, I have theta equals 7 pi over 12. So I'm going to multiply, first I'm going to try to get into degrees because it's easier to find it in degrees that way. So I'm going to have 180 divided by pi. Pi's cancel out. Multiply this out, this is going to give me 105 degrees. So if I make this right out here, 105 degrees looks somewhere right around here. Okay? And what I want to do is I want to find what this angle is. And so that's going to be my reference angle. My reference angle is basically if I take 180 degrees and subtract it by 105, so my reference angle is going to equal 75 degrees. But since I have my original thetas in radians. Let's convert it back to radians. So I'm going to go 75 multiplied by pi over 180. So then that ends up equaling 5 pi over 12. Same thing goes for b. So if I write b in here, it's going to be negative 295. So it's going to be somewhere right around here. And I want to find the reference angle, which is represented by the blue. And if I just take 360 minus it by the 295, I get a value of 65 degrees. So my reference angle in this case is 65 degrees. It's already written in degrees. I don't have to change anything. This portion here is really important when we are being able to evaluate trig functions. What this chart here is on my right is what each trig function will be, either positive or negative depending on which quadrant it's in. So we can dictate what the value is going to be of our trig functions by using reference angles, but also being able to determine whether they're positive or negative or not. And here are the steps to do that. First, you have to find the reference angle. Second thing is you have to evaluate the trig functions of your reference angle, and then to determine the sine of the trig function by looking at our chart here, respectively. So if we have the sine of negative 225 degrees, first thing I want to do is I want to find my reference angle. So if I make my box here and if I find negative 225, it looks like it's going to be something right around here. And so I want to find this reference angle, which is right here. And this reference angle happens to be 45 degrees. So technically what I want to do is I want to find the sine of 45 degrees. That happens to be one of their special trig functions, and then the sine of 45 degrees happens to be the square root of 2 over 2. But now I want to do is I want to take a look at my chart. If I look at my chart, I'm in quadrant 2, and the sine of quadrant 2 is going to be positive. So since it's positive, I get to leave this as positive. So the sine of negative 225 is going to be square root of 2 over 2. And you can check that in your calculator to prove that point. Second step in B is I have the cotangent of 5 pi over 3. So what I want to do is I'm going to convert this to degrees because it's easier to reference it with degrees. So I got converted here, so that's going to equal, so if I got 5 times 180, divide that by 3, so I got what, 300 degrees. So make this here, I go somewhere right around here, which means I have to find my reference angle located right there, and that happens to be 60. So basically what they want you to find is what is the cotangent of 60 degrees. And again, note that is a special trig function, and that is going to give us the square root of 3 over 3. Last thing we do is we look at our table, and cotangent looks like it's going to be represented as a negative number. So then all I got to do is just put a negative value onto that. So at the end, the cotangent of 5 pi over 3 is going to be a negative square root of 3, all divided by 3. And that is being able to evaluate trig functions at any angle. Hope this helps. Till next time.